Alright, so we are moving forward with the idea of alkenes, and in the last videos we saw alkenes, we saw the single bonds, and in this video we'll be talking about alkenes and why is it different. So alkenes, again, these are hydrocarbons, the same thing, and the difference here is that they have a double bond. So the carbon-carbon bonded to each other will have a double bond in alkenes. And if I draw the structure for this, it's going to look something like this. This is the most basic structure for an alkene. So this is something that we call ethene. Basically, here, this is a covalent bond. We did this in previous lecture as well. This is what? This is a covalent bond, right? And if I were to draw a dot and cross diagram to show you how the bonding works, how the electronic configuration works, so it's going to look something like this. So, for example, you have a carbon, and that is bonded to one more carbon here. And carbon, we know, has the valency of 14, which means it has the tendency to share 4 electrons, meaning it can gain 4 electrons to complete its outermost shell, right? And if you see here, you have got two carbon molecules, right? Two carbon molecules, meaning each individual carbon has the tendency to gain 4 molecules and complete its outer shell. So one carbon can gain 4, and the second carbon can gain 4, so total goes to 8, right? So here now, if I draw the structure like this, this is a hydrogen bond here, this is a hydrogen bonded here. So one electron, two electrons here, two electrons are here, and four electrons are at this place. I'll just highlight it here. Yeah, four electrons exist at this place. Okay, so now the outermost shell for this carbon is complete. It has two here, four here, and two here, which means it's now complete. And for this carbon, it has four here again because this is shared, so it has four here. You have one hydrogen being bonded here and one hydrogen bonded here. So you have two electrons here and two electrons here. So this is how the dot and cross diagram works. So this molecule here is C2H4, and this is the basic idea of an alkene molecule. Okay, and if we talk about, we say that alkenes are saturated. But if we talk about alkenes are unsaturated. Why? Because the reason is the double bond. This differentiation comes from the double bond and the single bond. Since alkene is a single bond molecule, we call it saturated. Since alkene is double bonded molecule, we call this unsaturated. And the difference here, basically, what the double bond actually does, it makes this whole molecule of C2H4, this double bond here is going to make this molecule reactive. Like we talked about, when we talked about alkenes, we say that alkenes are generally unreactive, and that's because the single bond in an alkene molecule like this single bond is very strong and it cannot be broken down easily. But when you talk about double bond, now double bonds are the bonds that are highly reactive, and you're going to study this in A levels. You're going to study the pi and the sigma bonds. We're not going that in detail right now, but just to remember that double bonds are always very highly reactive molecules. Okay, any molecule that has a double bond is going to be very highly reactive. All right, so this is the main idea of an alkene molecule. Now let's talk about, yeah, how does the general formula works. So the general formula for alkenes we already know is CnH2n plus 2. This one for alkenes, not alkenes. Okay, this is for alkenes. So we're to talk about alkene, so the general formula looks like this: CnH2n. There is no plus 2 for alkenes. And same concept applies here. This N stands for the number of carbon molecules Okay, and this N is the same here. Both N stand for the number of carbon molecules. So let's say if the examiner says that you have a molecule that has, you have an alkene molecule that has two carbon present in it. Okay, so, and you want to know the whole molecular formula. So what you're going to do, you're going to place this value of N, because this is the number of carbon molecules, so this is N. You're going to place the value of N in place of N. So this becomes C2H and 2. This is C2H4. And this is how you figure out the formula. So let's say if the value for this was, if the value for N was 3, you're going to do the same thing. C3H3 is C3H6. And this is how we figure out the molecular formula. Okay, so this is the general formula. And one more thing that we haven't it before is I've explained that in very much detail what is the homologous series and how every different family has its different homologous series. So right now we're talking about the homologous series of alkenes. Okay, and how does the homologous series of alkenes work? It works the same way. So the characteristics are going to remain the same throughout. It's going to be the same as the individual series, but there are only going to be differences when we talk about, let's say, when we talk about chemical properties, when we talk about physical properties, they are going to be different in each individual homologous series. And this is the concept of alkenes. Okay, all right.